Hello everyone, welcome to another session of Leetcode. Today we're solving partition labels, and this is a very interesting problem. And if you're someone who struggles with string problems, I think this is a pretty good exercise for you. So let's dive right into it. You have been given a string, and you have to divide this string in such a way that the partitions you create and the letters you have can only be in one partition. So for example, in this input, you can create a partition like this where every letter in this partition is not in other partitions. So you have A, B, and C. So you cannot have a partition like this because then A, B are in the remaining partition, right? And also the goal of this problem is to maximize the number of partitions. Otherwise, the question doesn't make any sense. Like you can just return the input string and this is a partition in itself. So yeah, it is important that you maximize the number of partitions you can create from this. All right, so now you've understood the problem, and I always talk about this in every problem video I do, that intuition is very important on how to attack a problem. So it's very obvious that if you look at the first letter, which is A, and you can say that an obvious partition would be to at least get to the point where I can see A. But that is not enough. You also have to make sure that the letters you are encountering between this also lie within this boundary, right? So for example, if you look, so in this particular input, you don't have a B or C after A, but you can imagine that if there's a B or C after this A, you have to extend your partition and include that as well. Similarly, another valid partition is this. And as you can see in this example, you extend till D, but then you also have to make sure that the letters between this are also included in the partition. So for example, E is not included until here, so you extend your partition and include E. So the total size of the partition becomes this. All right. It's a little tricky in the beginning, but once you get the hang of it, I think it's pretty easy. So let's dive right into it. By the way, I solve all these problems before I post these videos. So yeah, just FYI. Okay, and then, so we have to make sure that, okay, so first thing we need to do is we have to make sure that we have the rightmost positions for all these letters. And you know that all the letters given are in lowercase. So we can just take an input array and use that to store the indexes. That's what I'm going to do here. And then you want to store the rightmost index. So you can override the index for the letters which are repeating, so that's fine. So if you don't understand this, what this is doing is you're getting the ASCII value and then you're subtracting the ASCII value of A. So if you get a letter A, you will store at index 0, B would be stored at index 1, and so on. Now you need a starting index, and this will be clear in a second why you need this. So J is the pointer which will keep moving forward. So J is something which is keeping a track of your range, the rightmost range. and start is a pointer which is keeping a track of where the partition is beginning. And then you have already gathered indexes for every letter in this array. So here I'm just maximizing the J. So if that letter um, that you are looking at has a rightmost range, then you just update your J. And then if your I becomes J, or sorry, your I is equal to J, then you can say that you have safely traversed all the letters and they are all in your range, in your partition, um, in that partition, and then you can add that partition to the result and start over. And then just, so you need the size, so that would be j minus start plus 1. And since you have computed this partition till the index I, so the start would become I plus 1. And I think that's all you need to do. Yeah. So let's run this code. Perfect. Cool. Let's just walk through a quick example in case you didn't understand this completely. So in this example, the very first step I'm doing is I'm keeping a track of all the letters and keeping a track in a way that I'm updating with the uh, rightmost range. So I'm looking at A and I'm updating where is the rightmost A, and that is the value that goes into that array, and I'm doing that for every letter. So and then in this loop, I'm just scanning this string and uh, updating the range. The range is modified by J. And then if your I becomes J, so for example, if we come to this point at this junction where you're saying I is equal to J, that means you have safely traversed all these letters and they are within the range. So you just add that to the result and then you update your start position, which will be I plus 1. And then you do this process all over again. All right. Thank you for watching, guys. Stay tuned for the next video and I'll see you in the next one. Bye.